We're reading Chapter 29, Section 2, The Terrestrial Planets. The 9 planets of our solar system can be grouped into 2 main categories according to their basic properties. The inner 4 planets, called terrestrial planets, are close to the sides of Earth and have solid rocky surfaces. The terrestrial planets are Mercury, Venus, Earth, and Mars. In order from closest to farthest from the Sun, the next 4 planets from the Sun, called gas giant planets, are much larger, more gaseous, and lack solid surfaces. The gas giants include Jupiter, Saturn, Uranus, and Neptune. Pluto, the 9th planet from the Sun, has a solid surface, but it does not fit into each category. On the next several pages, we'll discuss each planet. Mercury. Mercury is the closest planet to the Sun and has no moons. Mercury is about 1/3 the size of Earth and has a smaller mass and radius, as shown in Appendix J. Radio observations in the 1960s revealed that Mercury has a slow spin of 1,407.6 hours. After Mercury completes one orbit around the Sun, it has rotated 1.5 times, and the opposite side of the planet faces the Sun. In 2 orbits, Mercury spins 3 times, and the side originally facing the Sun faces the Sun again. Thus, in 2 of Mercury's years, 3 of Mercury's days have passed. Atmosphere. Unlike Earth, Mercury has essentially no atmosphere, and what little does exist is composed primarily of oxygen and sodium, as illustrated in Figure 29.6. The daytime surface temperature on Mercury is 700 K or 427 degrees Celsius, while temperatures at night fall of 100 Kelvin, negative 173 degrees Celsius. This is the largest day-night temperature difference of all the planets in our solar system. Surface. Most of what we know about Mercury is based on radio observations and images from a United States space probe mission called Mariner 10, which passed close to Mercury 3 times in 1974 and 1975. Images from Mariner 10 show that Mercury's surface, similar to the Moon's surface, is covered with craters and plains, as shown in Figure 29.7a. The plains of Mercury's surface are smooth and relatively crater-free. It is thought that the plains were formed from lava flows that covered crater terrain, much like the Maria of the Moon. The surface gravity of Mercury is much greater than the Moon, and thus crater walls and peaks are lower and ejecta are shorter in length than those on the Moon. Mercury has a planet-wide system of cliffs called scarps, as shown in Figure 29.7b. Scientists hypothesize that the scarps developed as Mercury crushed, shrank, and fractured early in the planet's geological history. Interior. Although scientists have no seismic data with which to analyze the interior of Mercury, the high density of the planet suggests that Mercury has an extensive nickel-iron core, filling about 42% of Mercury's volume. The detectable magnetic field, only 1% of Earth's magnetic field strength, suggests that Mercury has a molten zone in its interior. Mercury's small size, high density, and problem molten interior zone resemble that Earth must be like if the crust and mantle were removed. These observations suggest that Mercury was originally much larger, with a mantle and crust similar to Earth's, and that the outer layers may have been lost in a collision with another celestial body early in history. Venus. Venus and Mercury are the only 2 planets closer to the Sun than Earth. Like Mercury, Venus has no moons. Venus is the brightest planet in Earth's nighttime sky because it is close and because its albedo is 0.75. The albedo of Venus is the highest of any planet. The thick clouds that are present in Venus's atmosphere could prevent an observer on the surface of Venus from seeing the stars. These clouds also prevent astronomers from directly observing the surface, except at radio wavelengths. In 1960s, radar measurements show that the surface of Venus is very hot and that Venus is rotating slowly. One day in Venus is 243 Earth days in length. Radar measurements also revealed Venus's clockwise spin, which is opposite the spin of most planets. The backward spin exhibited by Venus, called retrograde rotation, means that for an observer on Venus, the Sun would rise in the west and set in the east. Astronomers hypothesize that the retrograde rotation of Venus may have been caused by a collision between Venus and another body early in our solar system's history. Today, astronomers know a lot about Venus as a result of close-up observations made by several United States and Soviet, later Russian spacecraft. Some probes landed on the Earth's surface of the planet and made observations there, while others flew by. The 1978 Pioneer Venus and the 1989 Magellan mission on the United States used radar to map out 98% of the surface of Venus. Atmosphere. Venus is the planet most similar to Earth in physical properties, such as diameter, mass, and density, as shown in Appendix J, but its surface conditions are vastly different from those on Earth. The average surface temperature of Venus is extremely hot, about 737 Kelvin or 464 degrees Celsius, as compared to Earth's average surface temperature of 288 Kelvin, 15 degrees Celsius. On the surface of Venus, it is hot enough to melt lead. The atmospheric pressure on Venus is 92 atmospheres, such higher than the 1 atmosphere at sea level on Earth. The pressure from the atmosphere on Venus would make you feel like you were under 915 meters of water. The atmosphere of Venus is primarily carbon dioxide and nitrogen, as illustrated in Figure 29.8. How does this compare to Earth's atmospheric composition? Similar to Earth, Venus has clouds, but instead of being composed of water vapor and ice, clouds on Venus, shown in Figure 29.9a, are made of sulfuric acid and are 35 kilometers thick. If it were to rain on Venus, the rain would be sulfuric acid. Venus has a greenhouse effect like Earth, but Venus is more efficient. As you learned in Chapter 14, greenhouse gases in Earth's atmosphere trap infrared radiation that keep Earth at a higher temperature than those that would exist if there were no atmosphere. Carbon dioxide on Earth's greenhouse gases has a high concentration in Venus's atmosphere, which prevents infrared radiation from escaping and keeps the surfaces extremely hot. In fact, it is so hot that liquid water can't exist. Venus is the hottest planet, even though it is not the closest to the sun surface. The Magellan orbiter used radar reflection measurements to map the surface of Venus in fine detail. The surface has been smoothed by volcanic lava flows, as shown in Figure 29.9b, and it has only a few impact craters. The most recent global episode of volcanic activity took place about 500 million years ago, and therefore the surface of Venus is relatively young. Unlike Earth, there is little evidence of current tectonic activity on Venus, and there is no well-defined system of crustal plates. Interior. The size and density of Venus are similar to Earth, so the internal structure is most likely similar. However, astronomers have no seismic data with which to provide this. It is theorized that Venus has a liquid metal core that extends halfway to the surface. There is no measurable magnetic field despite the liquid core, which is probably due to Venus's slow rotation rate. Earth, shown in Figure 29.10, is the third planet from the Sun. Earth has unique properties when compared with the other planets. Its distance from the Sun is nearly circular orbit allowed liquid water to exit on its surface in all 3 stages: solid, liquid, and gas. Liquid water is required for Earth, and Earth's vast abundance of liquid water has been important to the development and existence of life on our planet. In addition, our planet's moderately dense atmosphere, which is composed primarily of 78% nitrogen and 21% oxygen and a mild greenhouse effect, also support conditions suitable for life. Precision. Earth's axis is tilted, as you have learned, and this tilt creates our seasons. As you learned in Chapter 14, Earth's axis is wobbling like a toy top that wobbles if you give it a small sideways push while it is spinning. The wobble in Earth's rotation axis, shown in Figure 29.11, is called precession. It takes Earth's rotation axis about 26,000 years to go through the one cycle of precession. The sideways pull that causes precession comes from the moon's gravitational force on Earth, as well as the sun's gravitational force. However, the sun's gravitational force plays a lesser part in the Earth's precession. Mars. Mars is the 4th planet from the sun and is the outermost of the terrestrial planets. This is often referred to as the red planet because of its reddish surface color, shown in Figure 29.12, which is caused by a high iron content in the soil. Mars is smaller and less dense than Earth, as shown in Appendix J, and has 2 irregular shaped moons, Phobos and Deimos, which are most likely captured asteroids. Mars has been explored by telescopes on Earth and with probes that have flown by, orbited, or landed in the 1960s. The United States sent a spacecraft, Mariner 4, to explore Mars. Later missions included Mariner 9 in 1971 and 2 Viking landers in 1976. More recent missions have been the Mars Climate Orbiter in 1998 and Mars Exploration Rover mission in 2003, which are all part of the long-term NASA plan to explore Mars for evidence of pre-existing life. atmosphere. The composition of Mars' atmosphere, shown in Figure 29.13, is similar to Venus's atmosphere, but the density and pressure in Mars' atmosphere are much lower, and therefore Mars does not have a strong greenhouse effect as Venus does. Although the atmosphere is thin, it is turbulent, so there is constant wind on Mars. Most storms in the atmosphere may last for weeks at a time. Surface. The southern and northern hemispheres of Mars have different types of surfaces. The southern hemisphere is a heavy, centered highland region resembling the highlands of the Moon. The northern hemisphere is dominated by plains that are sparsely cratered. Scientists theorize that great lava flows covered the once created terrain of the northern hemisphere. 4 gigantic shield volcanoes are located in the northern hemisphere near a region called the Terrestrial Plateau. The largest volcano is Olympus Mons, which is also the largest mountain in the solar system. The base of the Olympus Mons would cover the state of Colorado. It is 3 times higher than the Mount Everest. Mount Everest, an enormous canyon valleys mariners shown in Figure 29.14 lies on the Martian equator and splits the Terrestrial Plateau. This canyon seems to have formed as a fracture when the Terrestrial Plateau was uplifted more than 3 billion years ago. Other Martian surface features include dried river and lake beds, outflow channels, and runoff channels. These are all erosional features that suggest that liquid water once existed on the surface of Mars. Astronomers hypothesize that the atmosphere must have been much warmer, thicker, and richer in carbon dioxide, which would have allowed water to exist on Mars. Although there is a relatively small amount of ice on the poles, astronomers are still searching for water at other locations on the Martian surface today. Mars has polar ice caps covering both poles. The caps grow and shrink with the seasons on Mars. Martian seasons are caused by a combination of a tilted axis and a higher eroded orbit. Both caps are made of the carbon dioxide ice, which you may know as dry ice. Water ice lies beneath the carbon dioxide ice in the northern caps, shown in Figure 29.12, and is exposed during the northern hemisphere summer when the carbon dioxide ice evaporates. There may also be water ice beneath the southern cap, but the carbon dioxide ice never completely evaporates to expose the water ice. Interior. Astronomers are unsure about the internal structure of Mars. They hypothesize that there is a core of iron and nickel and possibly sulfur that extends somewhere between 1,200 kilometers and 2,400 kilometers from the center of the planet. Because Mars has no magnetic field, astronomers hypothesize that the core is probably solid. Above the solid core is a mantle. There is no evidence of current tectonic activity or tectonic plates on the surface of the crust.